So a definite integral we've already been doing. A definite integral is an integral from a number to another number. So we have been doing these mostly with graphs. Or possibly with tables, but mostly with graphs. So I have created a graph here, and I just want us to think about what this definite integral means. And after thinking about that a little bit, we're going to apply it to a more general form. So the graph of v of t is shown to the left. It shows the velocity of a car in feet per second traveling along a straight highway. Find the integral from 0 to 7 of v of t dt, and it should just say describe its meaning, not tell describe its meaning. So you can put that there. So if we're looking for the integral from 0 to 7 of v of t dt, and this is v of t right here. 0 is right here, 7 is right here. So we're looking for the area under the curve from 0 to 7. So that area underneath the curve, we've got a trapezoid here. You could break it into triangles and rectangles if you want. I'm just going to use the trapezoid. So it'd be 1/2. The height of that trapezoid is 2. The top base has a width of 2, and the bottom one is 7. So 1/2 times 2 is just 1, and then 2 plus 7 is 9, so we get 9 for our answer. Now, finding the integral from 0 to 7 of v of t dt is the easy part of this question, I think, because you're just finding that area. The difficult part of this question is describing its meaning. Okay, so let's label a couple things here. The x-axis here, that would be our time. And what is our time measured in? Seconds. So this is time in seconds. What would the y-axis be measured in? It is, no, not feet. It is feet per second. So this is the graph of velocity, and it tells us that the v of t is shown, and it shows the velocity of the car. So the velocity is going to be measured in that feet per second. So the units, to me, are very helpful in determining what in the world this means, right? So if I am talking about what this means, I have integrated. I have found the area underneath the curve. So the area of this, if I'm thinking of units for the area of this, then I would be taking feet per second, and I would be multiplying that by seconds. And seconds would cancel out, so my answer would just be 9 feet. Okay, so what does this mean as far as the car goes? Probably shouldn't say car, since it has in fact only traveled 9 feet in 7 seconds. It is a very, very slow car. Probably should have said a snail or something. This 9 feet, we know it has to be a distance because it's just feet, right? If it were acceleration, it'd be feet per second per second. If it were still feet per second, it'd be a velocity, right? So this 9 feet, this is going to be the distance the car traveled. From t equals 0 to t equals 7. So by finding that area under the curve, we can find the distance that it traveled. We can think about that with units. The other thing that we can think about is whenever we were doing position, velocity, and acceleration, our position, we usually use x of t for position. And then we used v of t for velocity. And we used a of t for acceleration. And we did several of those problems where we had like a position function and it would maybe ask you when the particle was at rest, what the acceleration was at this time, those sort of things. But whenever we first did these problems, we only knew how to take derivatives. And a derivative, if we take a derivative, that will get you to the next line, right? If we take the derivative of x of t, we get v of t. If we take the derivative of v of t, we get a of t. Well, now that we know how to integrate, integrating gets you back up in the other direction. So if we integrate the velocity, it's going to give us the position. If we integrate acceleration, it would give us velocity. So integrating from 0 to 7 is going to give us a change in position there. Okay, questions so far? All right, so the next slide still has the same graph, and it asks us to find the integral from 9 to, oh, that shouldn't say 9 to 18. I forgot to change that. I changed the graph and I didn't change this. Make that 7 to 10. And then down here on number 3, make that from 0 to 10. Okay, so if we find the integral from 0, not from, I'll mix it up, from 7 to 10 of v of t dt, that is this area under the curve. So it would be 1/2 times, we have a height of 4 for this one, and then you've got 1 and 3 as your bases, so you would end up with 8 for that one. Okay, and in this case, same scenario, so that is 8 feet. But since it's underneath the curve, it's not exactly 8 feet. What is it going to be instead? It is negative 8 feet. What does the negative tell you? Okay, velocity is different from speed. How is velocity different from speed? It has direction, right? So whenever we're given a velocity, it has a positive or negative direction. So whenever we integrate velocity, if we get a positive number, that means that the car was traveling in the positive direction, whatever that might be deemed to be. If we're on the x-axis, it'd be going to the right. And the negative is if it's going in the opposite direction. Okay, so we don't really know which way, if it's right, left, up, down, north, south, whatever, because it just tells us it's traveling on a straight highway. But this part here would be going in one direction. This negative 8, that's the other direction, the opposite direction there. So this might be 9 feet north. This might be 8 feet south, right? So here what we have, this tells us the distance car traveled in the opposite direction from t equals 7 to t equals 10 seconds. Okay. So, those two are pretty straightforward. 3 is a little bit different because 3, if we want the integral from 0 to 10 of v of t dt, we really can't do 0 to 10 all together at one time. We would break this up and do the integral from 0 to 7 of v of t dt plus the integral from 7 to 10 of v of t dt. And luckily, we have already found both of those. So we found the integral from 0 to 7. That was this area right here above the curve. And that was 9. And we just found the integral from 7 to 10, which was negative 8. And so whenever we do this, we get 1 foot. Okay, now let's talk about what this means. Now, the other times I've just said it's the distance the car travels, right? But if the car traveled 9 feet in the positive direction from 0 to 7, and then it traveled 8 feet in the negative direction from 7 to 10, how far did it travel altogether? It went 9 feet in one direction and 8 feet in the other direction. So that would be 17 feet, right? So the car traveled 17 feet. But we got 1 is the answer for our interval here, right? So what has happened here, it would be like if Lily asked to go to the bathroom and she walked to the bathroom over here. But then that bathroom was being cleaned, so she had to walk back to the bathroom over here, right? She is only the distance from my door down to this bathroom away from where she started. But she walked a lot further than that because she had to go down here and back, right? So her distance traveled is a lot higher than like the actual progress she made from one place to the other. So I could have up here said that what we can call this is the displacement. It's how far you are from where you started. Okay, so I could have called this displacement for number 1 and number 2. However, for number 1, the car was always traveling in the positive direction. So since it was always traveling in the positive direction, the distance that it went, its displacement was just how far it went, right? And from 7 to 10, it was always going in the negative direction. So I could just say that was the distance that it traveled. But for number 3, I cannot because it went in the positive direction and the negative direction. So this tells us that the car is 1 foot away from its starting position. And if they had given us something like north or south or left or right or something like that, we could tell this would be the positive direction, so whichever direction that might be. So this is the displacement that you have from the car. It's how far the car is from where it started. Okay. Now, I did all of this because I want us to think about how we could find this if we knew the x of t equation, right? So if I knew that x of t was the position of the car. So that means, like, if I have x of 0, that would be the car's position at t equals 0. If I had x of 10, that would be the car's position at t equals 10. So if I was wanting to know how far the car went, if I knew x, I could just say, or not how far the car went, but how far the car is from where it started, I could just take the position at 10, and I could subtract the position at 0, right? So if I knew that the car was at, let's say it's on a, going north and south, if I knew it had, at x equals 0, let's say I knew that it was at 0, 0, and then at 10, I knew it ended up at 1, or let's say at x equals 0, let's say it was at 8 feet to the north, and then at 10, I knew it was at 9 feet to the north. I could just say, well, 9 minus 8 gives us 1, that's how far the car traveled, right? So the integral from 0 to 10 of v of t dt is going to equal x of 10 minus x of t, x of 0. And in this case, the general integral of v of t, not the definite, but the indefinite integral, if we just integrate v of t, it would give us the position x of t plus c. Okay, so this brings us to another application of the fundamental theorem of calculus. We said that the fundamental theorem of calculus basically tells us that derivatives and inverses, derivatives and integrals are inverses of each other. Okay, so applied to let's see, we're gonna skip that. I don't want to do it. We're gonna skip that. We're gonna skip to this. So the fundamental theorem of calculus, as applied to definite integrals, tells us if f is continuous on the interval from a to b, and capital F is an antiderivative of f, then the integral from a to b of f of x dx equals capital F of b minus capital F of a. So just to think about this in terms of like position, velocity, acceleration, if I have the velocity of t and I'm integrating it from 1 to 4 with respect to t, what do I get if I integrate velocity? Which function do I get? It'll be position, right? Because if I have position and I take the derivative of it, I get velocity. If I have velocity and take the derivative of it, I get acceleration. So whenever I take the derivative of this, the integral of this, I get velocity, I get position. So that would be x of t. And I'm going to write it like this because this is some notation we're going to see. I would be the position from 1 to 4. And to evaluate that, I would take x of 4 minus x of 1. So this would be position at 4 minus position at 1. Okay, so that would be an application of the fundamental theorem of calculus here. Okay, if we look at the next one, I have the acceleration, and I'm integrating from 0 to 3. So Harper, whenever I integrate acceleration, which function will I get? Velocity. So I would get the velocity that would need to be evaluated from 0 to 3. And to do that, I would get velocity of 3 minus velocity of 0. So this would, if I integrate the acceleration from 0 to 3, that actually gives me the change in the velocity from 0 to 3, right? Because it's the difference in velocity at 3 and velocity at 0. So, the AP Classroom stuff wants you to do some complicated versions of this. So if you will look at the next picture, and it is a little bit small, but hopefully you can read it there. We are going to use the calculator for these. You can sort of tell by the answer choices we're probably going to need that calculator. Alright, so it says let f be a differentiable function such that f of 3 equals 2.345 and f prime of x equals the natural log of x squared plus 1. Okay, so if we integrate f prime of x, what will it give us? Just f of x, right? And so we know f of 3, it's asking us about f of 5. So if I set this up, if I integrate f prime of x dx from 3 to 5, right? When I integrate f prime of x, it's just going to give me f of x. But with a definite integral, it's going to have to be evaluated from 3 to 5, which means I would need f of 5 minus f of 3. So I'm gonna kind of get rid of this middle part right here. It's a notation we don't really need right now, but we might need when we get to the more difficult problems. So integral from 3 to 5 of f prime of x dx is going to equal f of 5 minus f of 3. We know what f of 3 is. It's given to us, right? So I'm going to write f of 5 minus 2.345. Now, f of 5 is what I'm trying to solve for. That's what I'm looking for. So I'm not going to replace it with anything. The integral from 3 to 5 of f prime of x dx. I have no idea. I could plug in natural log of x squared plus 1. We do not know how to integrate that yet. Or we're not going to know how to integrate that one ever, actually. We don't know how to integrate that. Plus, I have not shown you how to evaluate a definite integral yet. But your calculator will evaluate this for us. Okay? So if you will press F3, the second thing that you see there says integrate. So on your calculator, if you will press F3 and enter, you got the integral symbol there. We're going to type the equation for natural log of x squared plus 1. So natural log of x squared plus 1 And then, like the derivatives, you have to put comma x. And because we're wanting to do a definite interval, I could just do this. I don't know if it'll do it or not. Let me just see. Yeah, it will actually give us the equation for the integral if we want. Sometimes it can't do that. But we don't really want to know that equation. What we want to know is we want to know that definite integral from 3 to 5. We want this to be a number. So to do that in your calculator, you after your x, before you close your parentheses, you're going to have natural log of x squared plus 1, comma x, then do comma 3, comma 5. So that puts your limits there from 3 to 5. So you're going to type all of that in. You're going to hit enter. I probably should have, oh yeah, let's hit the green button before we hit enter. So we get 5.631 equals f of 5 minus 2.345. And so we could add the 2.345 to both sides. And when we do, we would get 7.976 for our f of 5, which hopefully is one of the answers it is B right there. Okay, questions? Okay, let's look at number 5. Selected values of the twice differentiable function f and its derivative f prime are given in the table above. What is the value of the integral from 0 to 3 of f prime of x dx? So some of these problems might look a little bit like they're like a Riemann sum sort of problem, but in this particular case, we don't want to do Riemann sums because we can find the exact answer. So if I'm integrating from 0 to 3 f prime of x dx, when I integrate f prime, I get f, right? And so I would have f of 3 minus f of 0. And f of 3, I can just find on the table really quickly. I get 10. And f of 0 is 4. And I get 6 as my answer. Okay. Questions? F prime is just put on that table to distract you, really, because you don't use it at all for the problem. Alright, we've got one more we're going to do, and I'm going to have you guys do a few yourselves. So, for 6, let g be a differentiable function such that g of 4 equals 0.325 and g prime of x equals this big equation here. What is the value of g of 1? So, I want to find g of 1, I know g of 4. So that tells me I probably want to integrate from 1 to 4 g prime of x dx. And when I do, I will get g of 4 minus g of 1. So I think for this one, I think I'm going to type that equation in y equals just because it's a big equation. So 1 over x times e to the x, that's e to the negative x, times cosine of x over 100. And so we're going you could do it from the main screen. Sometimes I just have a hard time with my parentheses whenever I've got so much stuff going on. So sometimes, especially if it's longer, I just like to put it into Y1. And so once you have put this into Y1, you can go back to the main screen. And we want to do the integral from 1 to 4 of g prime of x. So we will do F3. We will integrate. We will say y1 of x. And since it's in y1, we don't actually have to do anything else there. We'll tell it comma x, comma 1, comma 4, and close that parenthesis. And I probably should have hit the green button before I hit enter. Oh no, it gave me a decimal. Did you guys get the same thing that tried it? So we get 0.21557 equals g of 4 is 0.325. And so we could subtract that 0.325. And when we do, we're going to get negative 0.109, but that equals negative g of 1, so g of 1 is going to be positive 0.109, which is 8. Okay, questions? Right now, what I want you guys to do is, I want you guys to do 1, 2, and 3. I'm going to give you about 5 minutes or so to do that. Then once you've done that, we are going to come back together and make sure everybody's got the right answer. And once we do that, we will start on that second set of